This is Pavement Black.
Hi, everyone, and welcome to another episode of Pavement Black, the official podcast of the National Asphalt Pavement Association. My name is Richard Willis.
And I'm Brett Williams.
And we're going to talk about something a little bit different today. Typically, when people think about asphalt, we think of highways, we think of city streets, but there are numerous other uses for asphalt as well. In fact, if you look at most of the racetracks around the world or automotive testing facilities, asphalt is the predominant pavement type which is selected.
So when you think about that, one of the main questions I have is, why is that? Why do large auto manufacturer companies like GM, Porsche, and so on choose asphalt for their tracks, their proving grounds? Why do racing organizations choose asphalt for their racetracks?
So to help us dig into this a little bit today, we brought in Dan Stys. Dan Stys works with the PEA Group, who's a consultant for many of the automotive groups around Detroit. Welcome to the podcast, Dan.
Thanks, guys. Thanks for having me on today.
Could you just give us a little bit of background on yourself and your company as we get started?
Absolutely. My name is Dan Stys. I'm with the PEA Group. PEA Group is an integrated site development firm who's developed a specialty in test track design. I'm a licensed engineer in Michigan and in Arizona, and I developed a fascination for pavement and test tracks probably about 10 years ago as I started working more out the Milford Proving Grounds. Just a fascinating place where vehicle and development and construction and specifically pavements have come together. One of the specialties that we've developed over the years is design and rehabilitation of test track surfaces and test track in general. But our primary role in supporting the automotive manufacturers is to make sure that their test tracks are durable and that they stay within their operating window to make sure that they're still meeting their testing requirements.
So I think it'd be interesting to start off and maybe talk a little bit about what's happening on these proving grounds, what kind of activities the companies are using these facilities for, and why the companies are making large investments in these facilities.
These proving grounds are basically the places where they're validating and obviously developing all of their live vehicles. Typically on a proving grounds, you'll see people trying to validate, different suspension settings or validating tires or trying to break transmissions or basically bulletproofing their products before they bring it to market. We see vehicles with multiple tire manufacturers. All the tire manufacturers are bidding for the bid, right? So you'll see, how does each tire react with each vehicle? How does each shock, each spring? So the engineers are constantly trying to come up with the best combination to serve their product in the market.
So let's get this next question kind of out of the way because it's something that our industry will be very interested in is why asphalt? Why, if you look at proving grounds or some of these racetracks, why is asphalt the predominant choice for these facilities?
Well, I think for first and foremost, if I'm not mistaken, asphalt covers about 93% of all roads in the country. From a vehicle testing standpoint, it makes sense to test your vehicles in the environment they're going to be driven in, which is predominantly asphalt. Secondly, I would say some of the testing protocol and things that they have to do when you get into smoothness is a big impact on, and it's a lot easier to get smooth asphalt than it is smooth concrete. When you look at ride quality, it's a big deal. Asphalt generally comes in a smoother run. Cost to build is another reason that asphalt is used predominantly. We can generally put it down faster and get tracks up and running sooner than we can in concrete. And then I think finally, the last part I was thinking of is performance fine tuning. I think you have a little bit more latitude within the mix design to create unique surfaces than you do with concrete.
Could you maybe share a little bit about what might make an asphalt mixture on one of these facilities different than a typical highway in terms of how they're constructed or what is that mixture?
Generally they're the same. I mean, many of the tracks that we've been involved with, we're using highway mixes. But we do have to provide some additional specification to those sometimes depending on whatever the characteristics the engineers need to test. The asphalt binder is typically the same. They'll use the normal PG graded binders. Certain cases, they'll go to a polymer modified binder if they need to, if they need a high rut resistance, or if they're looking at improving the durability and try to decrease the raveling of the surface. In some cases, it's not an option. We can't use PMA. Sometimes the aggregates that we have to use are a little bit different as well, again, depending on what the purpose of the test surface is. If we have a high friction surface that we have to build, then we're not going to be using rounded river rock, right? We need high friction, high microtexture aggregates to be able to generate friction. And then typically, and more recently, most of our test track surfaces are using a virgin asphalt binder and aggregate mix on the surface. With the development of some of the wrap technologies and things that have come out more recently, we're starting to evaluate implementing more wrap into the surfaces as a value engineering or cost savings measure. But that's going to take a little bit of time to get the buy-off of the development engineers through different testing cycles to understand how that impacts the vehicle and their test results, because they have decades of testing that have been done on a surface where they've got a strong benchmark, and coming in and changing something like that it takes a little convincing to get that done.
Yeah, that's an interesting point, because when I think about test tracks, I immediately go to Auburn University, where we're testing the pavements, and the trucks are secondary.
Mm-hmm.
At the NCAT test track, where I spent 10 years of my life. And you have the flip side of things, where these people are more focused on the vehicles and how the pavements really interact with those. They want that to be a non-factor in everything. They want everything to be isolated back to the impact of their design and how they put their materials together. So with it being so focused on the vehicle and wanting that pavement to be a non-factor, I mean, I imagine the specs are pretty tight in terms of not just even the materials, but you were talking earlier about you want it to be a certain level of smoothness, so that you'll be able to understand if it's the shocks or if it's the road that are causing the oscillation in the vehicles. What are some of these challenges in terms of specs, and how do contractors handle this type of construction environment?
That's a great question. The specs are indeed really, really challenging, and not every paver is equipped with the equipment or the knowledge to really work with these types of specifications. So some of the things we have to deal with are ride quality. The manufacturers do many different tests. You know, a lot of it's for EPA testing. A lot of it could be for ISO testing, right? There's different testing protocols that the manufacturers have to meet, and that kind of helps define what those test surfaces need to be. So ride quality, we're typically looking for 40 IRI, 45 IRI at the most on an asphalt surface. So, typically we're doing, 3 lifts and measuring after each lift and making sure that we can hit that target IRI. We've had some stuff sub 30, which has been great, 30 inches per mile. You've got flatness as well. So you need to make sure that your screed is nice and consistent all the way across. You can't have any dips and valleys. I mean, typically on a test track, some surfaces were an 1/8 inch and 16 feet. So when you think about no 1/8 inch deviations across a 16-foot straight edge, that's pretty hard to do, especially when you start thinking about putting butt joints together. Friction, like I had mentioned before, it's kind of fun on proving grounds, because sometimes we get to build things with 0 friction using ceramic tiles or something along that nature, or we have to build things with a high friction level of 0.95 mu or something like that, and trying to dial in a mix. So it does take some special engineering and some local knowledge of aggregates and materials to make sure that you can hit those requirements. Sound absorption, there's an ISO test out there that the manufacturers have to certify to, that their vehicle doesn't emit too much sound, whether it's from the tires or whether it's from the engine or from the muffler in the exhaust system. So we have to design specific test surface, which is an ISO standard, that only has a certain amount of sound absorption. Surface texture, same thing, right? There are some tests out there that require a certain surface texture. So now you're looking at the gradation of the materials. How many fines do you have in it? What gradation ranges do you need to be to try to hit that surface macro texture requirement? Some of the others are sound reflection, durability, creating or building a dynamics pad that's super smooth and super flat, but also doesn't ravel under high tire loads is a challenge in some environments. And then I think that probably the biggest thing is consistency. There's not a lot of room for errors or segregation or anomalies within the paver, behind the paver, coming out of the screed where the surface texture changes, because that means friction changes. That means traction changes. That means there are areas that you wouldn't be able to certify on. So getting the mix out of the truck, getting it onto the ground, through not even the windrow machine, but the load transfer device, and keeping them smooth is a challenge. I think I kind of align it to, it's an exterior lab. So you think about it that way. You're creating a laboratory environment for these automotive test engineers to be able to do their job. And we have to make sure that those labs are correct for them to be able to do it. So one of the biggest things in the projects that I've been involved with is to be able to do this, it takes a lot of teamwork and communication. Right down to the aggregate supplier, getting the right rock to the plant, getting the plant to produce it correctly, consistently, with high quality assurance, the owner understanding how things are going on. From a contractor standpoint, we've talked about some of the knowledge. Some of the contractors in this area have kind of developed some processes to support these, since we're heavy automotive here in our area. There's a lot of self-quality control that they do. They have to do sometimes a lot of different testing on their own. Sometimes it's part of the contract, sometimes it's not, to make sure that the mix they're putting down is going to meet the requirements. So whether it's friction or sound, or sometimes there's, like I mentioned, there's allowance in the contract for a little bit of testing, but if you don't get it tested out, that's on you to kind of continue to try to evolve that mix to meet the specifications, or even the rolling patterns, to make sure that you're getting the right density and you're not densifying the surface too much. And sometimes we got to think of specialty equipment and specialty remediation. Some of these test tracks have large circle tracks, right, where it's they design them with a parabolic cross section. So you got a screed that breaks every 2 feet that you have to dial into the right cross section to be able to create a neutral steer situation around the test track at a certain speed. So again, not everybody has a parabolic screed. There's a couple in the country, I think. There aren't many. Finally, some of these things are so goofy. We always joke about this within the office is, we have to design tracks that are not just, perfect condition, but we have to also design some that are in horrible condition. You got to build in potholes, right, to try to break things. So some of those tracks are hand built, and when you got guys raking and tamping and, trying to develop the ride motion that the engineers are looking for. A couple of the other things that I think make this a little bit challenging is, many of the DOT jobs, you may get a percent within limits type thing, where you may get a pay adjustment on a contract because maybe density didn't meet it here or something. You typically don't have that on a test track. It either works or it doesn't work. And if it doesn't work, you're having to rebuild it. So there's really no pay adjustment, which makes it's a little riskier, right? Actually, it's a lot riskier when you have a lot of money on the line. And then I think, one of the biggest things that is, and I kind of alluded to it earlier, is teamwork and quality management throughout the whole chain is really critical. And I would say it's hyper sensitive when it comes to a test track, or even if you're looking at a high-end automotive facility, you say like Circuit of the Americas down in Austin, which is the new Formula One track that was paid a few years back. Super tight quality control, because you don't want this first surface to fail and it results in a really bad accident or something like that. So
you kind of touched on it. I was just kind of curious, have you seen much in terms of paving technologies that have started to show up on these tracks, maybe like 3D paving or intelligent compaction, or any of those technologies that are maybe helping with some of those tighter specifications?
Yeah, we've used some 3D milling and paving on a dynamics pad that we were involved with. I'm trying to think, and I believe we had the 3D on this paver and on the screed as well, to really try to dial this thing in as smooth as we can go. We have not seen as much on the intelligent compaction side. Not to say that the contractors weren't doing it and following that methodology, but some of it wasn't shared with us, and we didn't. It's not something that we've specified.
Well, I definitely really appreciate you taking the time to join us today, share some of the perspectives and a specialty use case for asphalt and some of the ways that asphalt really helps you achieve, the goals for these facilities. So I really appreciate you sharing that perspective and taking the time to join us today.
Well, that was definitely interesting. I was sitting here just thinking most of the time, because I was like, this is so different. It's a highway mix, but it's a highway mix like on steroids in terms of like your control and what's the expectation from it.
Yeah.
So
yeah, I liked that you described it as like building a lab with the pavement. So you're really, making it like your laboratory tool or whatever, and you need it to that precise of a, like standards, so that you can go out and test on that piece of equipment, basically. Yep. So yeah, I think that was good for sure. And I liked it. I thought you covered a lot of different perspectives.
All right, good. Well, hopefully your audience can get something out of it. It's definitely a unique topic. Appreciate the ability to share. It's something that's always been interesting to me, as growing up here in Metro Detroit and kind of being a car guy and trying to bring construction and vehicles together with the proving grounds.
Thanks, Dan.
Thanks, guys.
We asked earlier why asphalt was the reason why did these facilities choose asphalt? It's the same reason it's chosen on between 90 and 94% of the highways. It's because it gives the owner what it needs, the ability to quickly build a smooth and durable pavement that's flexible enough to meet the needs of the facility.
Yeah, I agree.
We just want to thank everyone again for being here with us today. My name is Richard Willis.
And I'm Brett Williams.
We just want you to remember, as you're driving around America's highways, someone from our industry paved it black.
Pave It Black is produced by Monica Dutcher of the National Asphalt Pavement Association, with podcast theme music credits to Coleak. You can find Pave It Black on most of your favorite platforms, including SoundCloud and iTunes. If you would like to suggest someone for us to interview, please email Richard Willis at rwillis@asphaltpavement.org. That's RWILLIS@asphaltpavement.org. Until next time, keep paving it black.